Good morning. Good morning to everyone. Okay. So, before starting with the competitive exam questions, we'll solve some of the questions today. So, before going for that, we'll have a discussion on actinoids, which can also be spelled as, okay, so one and all same, actinoids or actinides, one and all same, and this will be the general symbol for this group of elements. So can anyone tell me what will be that total number of elements which will be present in this group? Any one of you? What should be the total number of elements? Yes, good morning. Fast. So what will be the total number of elements present in this group? Any one of you? First, how many elements should be there in actinides or actinoids? General symbol is An. Ac is meant for actinins. So actinium is Ac. Now I have written An. So these are the elements which comes after the actinium, right? So like lanthanides, total elements should be here. It should be 14 elements. Since we are talking about F block element, total number of element which will be present in this group will be 14, 1, 4, right? Now, these elements as we have discussed can also be called as 5F series. It will be called as 5F series. So can any one of you tell me, in case of the 5F series, which will be the first element? Which will be the first element? Which should be the first element in 5F series? Fast. Which should be the first element in 5F series? Any one of you? It will be thorium. It is nothing but thorium, right? So which will be the last element? It will be lawrencium, right? So that's where we have the thorium and lawrencium. So from 90 it will go up to 103. 90 to 103. What will be the general electronic configuration? General electronic configuration. This type of question you can expect in your competitive exam also. So general electronic configuration for actinoids, An, not for specific. I am talking about 5F series. What should be the general electronic configuration? It will be radon 5F 1 to 14
6D
0 to 2
7S2.
Okay, so very good. So that's where we have the general electronic configuration, right? This is where we have the general electronic configuration. Now, if I see this general electronic configuration, so one of the element which is actually in its ground state, will not have this one, that is thorium. So this is the one which is actually having 5F0 in its ground state. Please remember all these points. Okay? So that's where we have the actinoids or actinins. Now when I am talking about these elements, whether they should have the colors or whether they should, it is there, right?
Yes, colors.
Brief discussion, okay. So whether they should show the colors,
Yes.
like 4F series where we had colors, right? So, but with respect to the 4F series, one thing you should remember, they will be having narrow spectrum. Okay? So, although there is a presence of FF transition, but unlike D block element, 4F series will not have wide range. They will have the narrow spectrum. When it comes to 5F series, once again, they will form the colored ions. They will form the colored ions. That is due to the FF transition, no doubt. That is due to the FF transition. Due to that, 5F series will also have the colored ions. Some of them, many of them will be colored ions. Okay. Now, compared to 4F series, listen to me carefully, compared to 4F series, 5F series will have the wide range, same as that of the D block element. Here also we can have the wide spectrum. They will not have the narrow spectrum. They will have the wide spectrum. So with respect to the colored ions, 5F series will mimic the D block element, not like 4F series. So the reason is very simple. Since 5F is still much more outer to that of the 4F. 5F is much more outer, because if we take the atom, so that's where 1, 2, 3, 4. So we will be having 4F here. So that's where I will be having 5F here. So that means 5F is little more outer compared to 4F. That means they are away from the nucleus. So the transition will be very easy. Okay. So therefore, due to the involvement of 5F subshell for the FF transition, so therefore 5F series elements, that means actinoids, they will have the wide range of spectrum with respect to the colors. They will have the wide range of the spectrum. All of you have understood? So that's where we have the actinoids. Whether I am clear? And please remember, most of the actinoids, or all of them I can tell, all of them, they are radioactive. So therefore they are having short lifespan. Many of them are having short lifespan. That means their chemical properties, study of their chemical properties will be bit difficult due to their radioactive nature. And many of them, here I can tell all of them, here I can tell many of them, they are synthetic. Man-made. They are not naturally present. Many of them, they are man-made. So that's where we have the actinoids, which are not present naturally in the nature. It will be prepared, or it was prepared by the humans. So that is the speciality of these elements. So therefore, when it comes to chemical properties, so same as that of the 4F series, even they will form hydrides and all. Some of the chemical properties has been studied, but still, when it comes to chemical properties, one thing here is it is difficult to study with respect to these elements due to their radioactive property. And another very important thing here is, Since they are radioactive in nature and many of them are synthetic in nature, with respect to their chemical properties, has gained less importance compared to 4F series. All of you have understood? So that's where we have the actinoids. Now, when it comes to actinoid contraction, this is also important, same as that of the lanthanoid contraction. Now, some of you should tell me what you mean by lanthanoid contraction. Same way we have the actinoid contraction also. Some of you can tell me what you mean by actinoid contraction. Lanthanoid contraction. Do you remember? So lanthanoid contraction is nothing, it will be difficult to type, I can understand. So lanthanoid contraction is nothing but decrease in the atomic size in the lanthanoids and the next elements due to the less shielding effect shown by the 4F subshell. Okay? So there will be decrease in the atomic size along the period more than the expected. That's where we have the lanthanoid contraction. And we have discussed what is the reason why lanthanoid contraction is there and what is the consequences or what are the consequences of those lanthanoid contraction. Right? Now same way when it comes to actinoid contraction, this is nothing but decrease in the, it is also nothing but decrease in the atomic size, of the actinoids, more than the expected, as there is an increase in the atomic number along the period. Right? So what is the reason why actinoid contraction is happening? So which is due to the least shielding effect, by the 5F subshell, All of you have understood? So that's where we have the actinoid contraction. Now when it comes to consequences of actinoid contraction and all will have not much importance, because as I told, actinoids, they are radioactive in nature. And they are having short lifespan. So same as that of the lanthanoid contraction, here also we have the actinoid contraction. But please remember, when it comes to definition, if 1 mark question it has been asked, then don't forget to mention 4F for lanthanoid and 5F for the actinoids. If you interchange that one, then you are going to lose the marks. So otherwise, if you are not remembering that one, you can simply tell it as due to the less shielding effect shown by the F subshell electrons on the outer shell electrons. That is also fine, since it is specifying a wrong one. Okay? So all of you have understood? Okay. Now we will come to the next one. Unlike lanthanoids, where 4F is bit near to the nucleus, here 5F is bit more far from the nucleus. So due to that, they can have the oxidation state same as that of the D block element. Wide range of oxidation states. They can have the wide range of oxidation state. Please remember, common oxidation state. Please remember, common oxidation state shown by these element will be as that of the lanthanides, which is that one. Common oxidation state which will be shown by these elements, which is that one. Can any one of you, which is that one, which will have the common oxidation state? Same as that of the lanthanides, that's what I am telling. Which is that number? I want you to write the number. Which is that common oxidation state shown by actinoids, and it is same as that of the lanthanides. Which is that? Any one of you? Which is that common oxidation state shown by these element? Wow, no one is writing. Any one of you? Which is that common oxidation state shown by actinoids? And I am giving a hint by telling that it is same as that of the lanthanides. Which is that common oxidation state? Yes, someone should tell me the answer. That is, I am waiting for the answer. Yes, now it came. Fine, good. That's where we have the +3 oxidation state. Okay, both of you are correct. So the common oxidation state, please remember, lanthanoids and actinoids, it is same. That is +3. But since there is the involvement of 5F, which is outer to the 4F, therefore actinoids can have the maximum oxidation state. Actinoids can have the maximum oxidation state up to +7. Up to +7. Right? That's where it differs from the lanthanides. It can go up to +7, same as that of the D block element. Especially we have plutonium and americium. So these are the two elements which can show up to +7. But when it comes to higher elements, that means as we move with respect to atomic number, I am telling, not with respect to atomic size. As we move to the higher elements with respect to atomic number, that means which are present on the right side of the period. So in those elements, +3 will be the one which will be shown by those elements. But the elements which are present in the beginning, and it will come up to americium. So those elements will have, or it can show up to, or various oxidation state, and these two can show up to +7. But last few elements, okay, so they will show only +3 oxidation state. That is due to decrease in the atomic size. Fine. So that's where we have the oxidation states of the actinoids. That's where we have the oxidation state of the actinoids, which can show +3, +4, +5, +6, +7. So maximum is +7. Why this difference is that? That is due to 5F subset which is involved here. Any doubts? So in that way, those elements which are after uranium, uranium is the third element in the 5F series. After uranium, whatever comes, they are called as transuranium elements. They are called as transuranium elements. So what are transuranium elements? So these are the 5F series element. These are the 5F series element. These are the 5F series elements which are present after the uranium. So that's where we are specifying that they should be 5F series only. We should not go to the P block element because they are also after uranium only. So I am specifying that they should be F block element only by mentioning them as 5F series element, and they should be present after the uranium. So whatever plutonium, americium and all I told, they are all examples for transuranium elements. All of you have understood? So naturally, when it comes to application, unlike 4F series where we have discussed about mish metal and all, here the major application will be with respect to that radioactivity. Especially uranium, thorium, they are all having some of the application with respect to nuclear reactors. They have the application where by using that fission reaction and all, they can use it for energy production. Fine? So that's where these actinoids, they will be having application. That's where we have the application of the actinoids. They will be majorly used as energy producers due to the radioactive property, due to the nuclear fission reaction and all. Okay? So by this, D and F block element, it is completely done. Okay? So any doubts? Any doubts? Then what is the difference between lanthanides and actinoids? Sometimes they will ask what you are going to write. Okay, that one we have to mention. What will be the difference between lanthanides and actinoids? So first point, you can mention that 4F series, and you can mention here as 5F series. That means you are mentioning that they are 4F block, they are 5F block. Then what else? Okay. So they will be having narrow spectrum. Here it should be wide spectrum with respect to the color absorption, and here it will be narrow spectrum. Here it will be narrow spectrum. Then, okay. So most of them are radioactive and are synthetic. Here, naturally present in the nature. Right? So this is another point. Next point. Next point here can be, here it will show higher magnetic momentum. Higher magnetic momentum. Why? Because 4F, which is a bit near to the nucleus, but here it will be having lower magnetic momentum. Lower magnetic momentum. Fine? So these are some of the points you can mention. These are some of the points you can mention. sometimes they will even call, they will form more basic compound, they will form less basic compound, even that one is there. Actinoids will form more basic compounds. Okay, actinoids will form more basic compound. Forms compounds. And compound short form I am using. Forms